In the last section of Chapter 9, we're going to solve quadratic systems. And if you'll remember, a system of equations is a group of two or more equations. And the solution is where the graphs of those equations crosses. And if you'll look at my lovely little drawings, what we'll graph first, or what we'll solve first, are systems that are one line and one conic section. So if we've got an equation of a line and a conic section, those two equations, we can have either 0 solutions, 1 solution, or 2 solutions, depending on, does our line not cross that conic section at all? And in that case, we're going to have no solutions. If that line touches the conic section in one point, then we'll have one solution. If it actually crosses it and touches that conic section in two different places, we'll have 2 solutions. So as you're solving those, that's just the number of solutions that you can have, so that you can know, oh, well, yeah, no, this isn't even a possibility. I can't have 4 solutions. All right. 3 different ways we're going to solve these. The first is using your graphing calculator. You've been waiting all year. Now you get to use it for real. Okay, in order to solve with your graphing calculator, you've got to first solve each of those equations for y, because that's how you actually enter that equation into the calculator. So if I give you these 2 equations, you'll simply solve each one of them for y, and then just punch them into your calculator and let your calculator graph it for you. So the first one is y squared minus 7x plus 3 equals 0. To solve that for y, we're going to keep the y squared on one side and move the other 2 to the other side of the equation. So we'll add the 7x and subtract the 3. And now, in order to get the y by itself, we're going to take the square root, and you know that. And now be careful. When you take the square root, remember you could have the positive of that square root or the negative of that. So y is now going to equal plus or minus the square root of 7x minus 3. So this actually is a representation of 2 separate graphs, 2 separate equations. So when you enter it into your calculator, make sure you enter it as 2 separate equations. Y equals the square root of 7x minus 3 and y equals negative of the square root of 7x minus 3. So that's 2 equations. To get your third equation, you're going to solve 2x minus y equals 3. I would add the y to make it positive. And so you're going to keep your 2x, and then to get your 3 to the other side, subtract it. So y equals 2x minus 3. And now if you put those 3 equations into your calculator and let it hit graph so that it graphs them, and then you find the intersection of those equations, you should end up with the point 4, 5. So go ahead and do that now. Pause and put those into your calculator, play around with it a little bit, and see what you can figure out. If you don't have a graphing calculator, come to class and you can borrow one. I'll see if I can bring one to class also. Okay, so without further ado, that's graphing calculator. Play with it, get it figured out. We'll do some in class when I can actually point at the buttons with you. 2 other ways to solve quadratic systems, and you've solved these with linear systems already. You've used these ways of solving by substitution and elimination. Let's just jump right in with this equation, with this system of equations. Let's use substitution. And remember, with substitution, what you do is you solve one of the equations for one variable, and then use that solution, the resulting equation, as a puzzle piece. And in this case, this second equation is already solved for y, so we're going to use this whole x squared plus 6x plus 7 as a puzzle piece and put that into the other equation for y. So we're going to end up with 2x plus this whole, plus y is this whole thing. So x squared plus 6x plus 7 equals negative 5. Okay, the reason I put that in the parentheses in this case, because we're adding it, it doesn't really matter. But if this were to be 2y or negative y, we've got to remember that whatever we're multiplying by needs to go through every term in that equation, or in that part, in this case, trinomial. It could be a binomial. So make sure that you keep it in parentheses until you recognize, okay, do I need to multiply? If this is negative, then every part of this, this trinomial needs to become the opposite of what it is. You need to multiply by that -1. Or if it's 3 times this whole thing, make sure each part gets multiplied. Okay? All right. So now in this case, though, we're simply going to combine like terms because we're just adding it. So we're going to combine the 6x and the 2x and get 8x plus x squared. And actually, you know what? While we do this, let's move it and put it in the correct order, in descending order. So let's put the x squared first, plus 8x, and let's go ahead and add the 5 to both sides at the same time. 7, 8, 9, 10, 11, 12, plus 12. And that equals 0 because we've moved that over. The reason we did this, remember, we're solving. And when we solve, now we want to factor. So x times x is x squared. They're both positive. And 12 is 6 times 2. 6 times 2 is 12, and 6 plus 2 is 8. So now for x, my solutions are either -6 or -2. But I'm not finished because I don't just have x, I also have y. So here's the trick. You've got to put in each of these x's back in to get a y to go with each one. So we're going to put in -6, and I would just go ahead and put it in this one because there's not a squared term, but if you want to put it into the other one, it should work fine. So go right ahead. So 2 times -6 plus, whoa, we don't have a y, equals -5. So 2 times -6 is -12 plus y equals -5. Add 12 to both sides. So y equals 7. So one solution is -6, 7. And go ahead and put it into the other solution also, into the other equation also, to make sure we don't have any extraneous solutions. -6 squared is 36. -6 times 6 is -36 plus 7. And that does equal, y is 7, and these two positive and negative drop out, so 7 equals 7. Yes, this solution checks out. So you've got one more x, so put that in for the other equation. 2 times -2 plus y equals -5. 2 times -2 is -4 plus y equals -5. Add 4 to both sides. Y equals -1. So now we have the solution -2, -1. So now go back in and let's check it just to be sure. -2 times -2 is +4. -2 times 6, so -12. And plus 7. And that's going to be 7, 8, 9, 10, 11. That's going to be -1. And y does equal -1. So both of these solutions check out. So we have 2 solutions for this problem. Okay? Now, if you have a quadratic system, if you've got a system of 2 or more quadratic equations, which means you've got squared terms involved in both of them, now we've got more possible solutions. You still can have 0 solutions. You can still have 2 conic sections that don't meet at all. You can still have one solution where they meet at one point. You can still have 2 solutions where they might meet, they might touch at 2 points. When they start crossing each other, you're going to either have three solutions or 4 solutions where they actually cross in as many possible ways as they can. So you either have 0, 1, 2, 3, or 4 solutions. So when you start having squared terms in both equations, you can have up to 4 solutions. So you got to keep solving x's and y's. So let's solve this system using elimination. And let me see how much room I have to go so that we've got plenty of space. We'll just move it down so that I've got plenty of space here. All right. So when we're using elimination, in this case our x squareds match except that they're both positive and we want one to be negative. So we can multiply through one of your equations by -1, if you'll remember. So, but make sure that when you do this, you're lining up like terms. So we've got x squared minus y plus 3 equals 0. Make sure that you line up the x squared, and then you've got a y squared, but you don't have a y squared up here. So let's move this over just a little bit. And we're going to have plus y squared here, and this is going to equal 9. Do you see why I lined that up that way? And now in this case, we're going to multiply through by a negative 1. So everything is going to be negative. And then we're going to add them together so that these drop out. And we have negative y squared minus y plus 3 equals negative 9. We did that in order to eliminate our x squared terms. So now we only have y and y squared terms, so we can actually solve this. Okay? And what I would do in this case, let's see, a couple of things at once here. Let's add 9 to both sides, and then let's multiply through by a negative 1 to get rid of the negative coefficient on our y squared. Can you do both of those steps at once without being confused? So we've got y squared plus y, and this becomes negative 9, 10, 11, 12 equals 0. Okay, so now when we factor, we've got y times y, and a negative term here means plus and minus, and we want plus 1, so plus 4 minus 3 will give us that solution. So now our two y possibilities are y could be negative 4 and it could be positive 3. Now remember, we set these, I hope you can do that in your head too. I set this equal to 0 and solved, so it moved the 4 to the other side of the equation, and that's why it's the opposite. Okay, so negative 4 and 3 are our possible y solutions. So now, in order to finish solving, we've got to put both of those back in to our equation. I was going to use a different color. There you go. Back into our original, one of our original equations, and solve for x now. And let's use this first one simply because we don't have a y squared, and either way is fine. Either one will work. So negative 4, so x squared minus a negative 4 is plus 4 plus 3 equals 0. So we're going to, so 4 plus 3, so x squared equals negative 7. If you square a term, can you ever get a negative number? There's no way. There's no way to square a term and get a negative number. So negative 4 is an extraneous solution, and that won't work. So that one's not going to work. So let's move on to the 3. X squared minus 3 plus 3 equals 0. So minus 3 plus 3, x squared equals 0. Is that a possible solution? Sure. X squared could be 0. 0 times 0 is 0. So 0, 3 is your only solution in this case. All right. So lots of stuff. 3 different ways to solve. You can either plug it into your graphing calculator, and actually I will have a section where I will say use your graphing calculator for these. All right, and so what I want to see on your paper is where you solved for y. That's all I'll need to see on your paper, and then your solutions. Step 2, the substitution method. There's a whole section that says solve this by substitution. I must see your work. I need to see where you put in the x for the other x, or the y for the other y. And I need to see where you're substituting. And then the third form of elimination is that last section. And I think on the last section, it just says to solve it. So you can use any of there's some that will work better in some, and some that will work better in others. So, all right, you should be able to do this. I think I've covered it. So I'll stop talking and get busy.